Good afternoon, ladies and gentlemen, or should I say good morning, dear distribution partner and customers. Welcome to the second imes-icore webinar. Thank you very much for your participation and interest in this webinar today. My name is Michael Pawlowski. I am the Regional Sales Manager for Europe at imes-icore. I'm working since more than 20 years for imes-icore, starting my education here, and after the education I was working in the service team. Since more than 10 years I'm a part of the sales team. Together with my colleague Alexander Funk, who is the head of project and product management, we want to explain the imes-icore AM printer to you. Alex, maybe you can kindly invite you by yourself.
Hello everyone, I'm Alex. In different parts of our webinar, I would like to show you the special areas of the 3D printing system directly on the printer and unpacking and sealing station. I will show you the individual modules of the system and explain them in more detail.
Thank you, Alex. Last year, in the first webinar, my colleague Sebastian Henkel spoke about our 150i big best-in-class machine and the newest machine series 350i X Pro, which is available for the market since some months. Today, we want to introduce to you our AM100 printer with the possibilities and innovations we have. During the webinar, you can ask questions, use the chat function, and Alex and me will answer these questions the next days via email or through this webinar. We will talk about machine selling points and arguments indicating the effect for AM100 printer. Okay, let's start the presentation and take a look into the agenda. In this webinar, we want to take a closer look into the technical specification of the AM100. What news and new developments are there? What are the main product features of the AM100? Which accessories are required? What is the unique selling point compared to other printers on the market? In this presentation, we will explain the CAM and the hybrid workflow using video animations. These videos can later be downloaded from our Dental Smart Market. During the presentation, we will switch live to Alex, and he shows and explains in detail the specific areas of the AM100 and AMpure. Let's have a look on the AM100. As you can see, the unit price for this unit is 121,000 euro. On the technical side, we have the powder supply with 25 kilogram powder. This guarantees us a 24/7 production. With the 250% overdose function, we are able to look ahead if cartridge is empty, and in this case, the printer takes the next cartridge to build the job. Loading the machine with prepared new powder during the ongoing production process is possible, of course. A 200-watt fiber laser is built in, and we are able to produce up to 500 units per day. The power supply connections are standard, and a high tension current connection is not necessary. The powder and cartridge system is certified and quality tested powder for the CORiTEC AM100 system. Supplied ready to start in the proven form, the powder container also serves as a supply container in the machine. The material will be fed directly into the process without secretious filling and getting in contact with the powder. Alex, please show and explain the function of the AM100 and cartridge system on the unit, please.
The power supply of our printer AM100 is located in the upper left-hand area of the machine. The unique feature is the closed cartridge system, which is easy and convenient to handle. The revolver module has a capacity of 5 powder cartridges. One cartridge contains 5 kilograms of the metal powder. With this special solution, we have reduced the powder contact to the minimum. Fresh powder is packed and delivered in special cartridges. The operator simply has to screw the interface onto the cartridge and enter the initial information about the material and fill level in the user interface. The cartridge is now ready to be used in the printing process. So basically, we have two different types of cartridges. One type is the overflow cartridge with the black safety ring, and the other type is supply cartridge with the blue safety ring. This allows the operator to recognize directly which type of cartridge and which material he has. Due to integrated NFC tags in the cartridges located in this part of the interface, the machine automatically recognizes which cartridge has been inserted. The status and fill level of the cartridges is displayed in the user interface. The supply of fresh material into the building process is completely automated. Now I will show you the process chamber of the printer. The door is opened by clicking the button in the user interface. In the front area of the machine is the protected gas extraction tube. You can take it out to have a better accessibility, for example, when you clean the process chamber. On the left side of the process chamber, you have the powder dosing system, which ensures a continuous powder flow during the building process. Right here, we have the coater. The coater applies the powder over the building plate. It moves from left to the right. This means from the powder dosing system to the overflow. The 200-watt laser is integrated on the top of the process chamber to ensure that you always have the whole building plate covered with powder. The conveyor system provides some excessive powder. This excessive powder is transported by the coater into the overflow slot. It falls into the funnel below and is collected there. By activating the operating button on the user interface, the excessive powder will be transported into the overflow cartridge. So how does the laser melting process in our AM100 basically look like? The building plate is clamped into the building module and aligned to the base plate. The coater spreads very thin layers of 20 or 40 microns of metal powder over the building plate. The laser on the top of the process chamber melts the powder in the areas where the components are located. The building plate is gradually lowered by the specified height. The powder is spread over the building layer by layer, and the laser process is progressing. This continuously generates the 3D printed parts. After the printing process is complete, the building plate is lowered to a safety position in the building module. The printed parts are surrounded by loose powder. To remove the components from the building module and free them from the loose powder, the module must be transported to the AMpure unpacking and sealing station. So first of all, you have to disconnect the plug to put on the the safety cap. Afterwards, you lower the levers on the right and left side of the building module. And then, with the help of the trolley, you transfer the building module to the AMpure. This is the trolley for transportation of the building module. So, Michael, go ahead with the presentation.
Thank you, Alex. Thank you very much. Let's go forward with the presentation. The AMpure, with the unit price of 45,000 euro, is a 2-in-1 unit. It is an unpacking and receiving station in one. The customer has the big advantage that he can unpack his building plate in the unpacking station and he will not lose the powder. Also, he cannot get in direct contact with the powder. After the unpacking, the remaining powder will sieve automatically for reuse. For some markets, we have the AMpure Lite with the unit price of 30,000 euro. For markets which are not so sensitive in relation of powder handling. Therefore, we have the option to order only the AMpure Lite, which is the sieving station. The powder which was used in the AM100 can sieved in the sieving station and can reuse in the AM100 printer for new building jobs. Alex, please explain us more about the function and using of the sieving and unpacking station.
In this step, I will show you the sieving and unpacking station AMpure. Here we have basically the same system as in the printer AM100. You disconnect the safety cap from the building module, put on the plug, and then you can fix the building module mechanically with the help of the levers. When the doors are closed, the buttons on the rear wall of the unpacking chamber can be operated by using integrated rods. You can see the operating buttons here. The loose powder surrounding the components can be swept into the overflow slot on the right side of the unpacking chamber by using a brush. From the overflow slot, the powder falls down into the funnel and will be automatically conveyed into the overflow cartridge below. Powder residues on your parts and in the unpacking chamber can be removed by the integrated vacuum cleaner connection. So again, as soon as you open the door, all the powder should be removed and you have really minimized the powder content. The focus is on a really easy operation for the user. The sieving station is located on the left side of the AMpure. On the upper position, you have a slot for the overflow cartridge. The full overflow cartridge will be removed either from the slot in the printer or the unpacking station and inserted here. Connected by pushing the lever in the upper position. Insert an empty supply cartridge into the slot at the bottom and connect it. As soon as the machine recognizes that there is a full overflow cartridge and an empty supply cartridge, the sieving process starts automatically. The operator doesn't have to perform any additional steps. It stops sieving automatically as soon as the overflow cartridge is empty or the supply cartridge is full. After the recycling process, the supply cartridge can be returned to the powder cycle and reused in the process. This means that only a very small amount of the powder is lost. Our color coding system, for example, blue handles and levers, indicates to the user where certain operating steps need to be carried out. This minimizes the error rate enormously. In addition, various operations on the system can be performed in parallel, thus greatly reduce the operating effort. So, Michael, please continue with the presentation.
Alex, thank you very much for the nice and detailed explanation of the sieving and unpacking station. And we will continue with the presentation. What's new? The latest development of the imes-icore is the integration of the titanium powder into the AM100. This means that with this printer, you are able to use titanium and cobalt chrome. We cover both materials and can print all indications and dental restorations. Existing printers, which you installed in the market, can be upgraded for titanium, of course. The next innovation is that we give the customer the opportunity to choose between two different parameters with which the printing should be started. The difference between the two values of 45 and 70 microns is obviously not noticeable, but rather can be seen under the microscope. 70 microns you can use for faster and mass production. The printing time with 45 microns is approximately 11 hours for the complete square plate. With 70 microns, your printing time is 30% faster and shorter. Up to 250 units can be printed in this time. The next improvement is that customers who has one or more other printers in their company and using the Octon software, they are able to add AM100 into the Octon software. imes-icore and Octon close a collaboration together, which means that the Octon slicer software is supporting AM100. This is a great opportunity, cost-effective method, and advantage for customers which have other printers installed in their lab. You can add the AM100 in your existing workflow, which you have in your lab, and the digital workflow don't need to be adjusted by you. As we know right now that both materials, cobalt chrome and titanium, are supported, we have not limitation of indication with the both materials. Crowns, bridges, abutments, and multiple dental constructions can be printed. Instead of milling or casting removable partial dentures, you can print removable partial dentures too. Depends on the size, we are able to put and print between 6 to 12 removable partial dentures in one job. The biggest advantage of the AM100 system is that the hybrid processing with imes-icore machines is possible without limitation, and it's integrated in the complete digital workflow. For the hybrid process, you take the round building plate of 115 millimeter in diameter and print on this plate. After the printing, we put and use this round building plate in our imes-icore machines. You can print high superstructures in titanium and or cobalt chrome and remill after printing the implant surfaces directly in the imes-icore machine. The milling and the printing time together is faster because in one job cycle, we can put different indications in one plate. The hybrid solution is available for the 350i series and 650i. This step we'll describe more in detail in a video later. As the fact that imes-icore is the only company which is offering a complete validated workflow for the hybrid process with own products, additionally to the machines and powder, you need only ICAM V5 software and the ICAM hybrid add-on module. ICAM AM is the slicing software for the printer. It means that imes-icore tested or validated these three software modules with approved powder and ensures a high precision result after the printing and milling. With the AMconnect remote access, you are able to monitor the printing process from your home or wherever you are. A camera is built in the AM100, and from wherever you are, you can monitor the printing job. You can see the remaining time of the current construction job, and for example, in case of an emergency, you can abort the job. For using the AMconnect, you need a PC or a laptop or a mobile phone with internet connection. The CORiTEC AM100 NHI is a friendly and easy operation software of AM100. With only 6 clicks, you can start the printing job. The software guiding you step by step, so you are not able to make a mistake. The design is very simple, intuitive, and reduced to the minimum. It leads you through all of the steps. You can go through the menu sections and check if the machine is prepared correctly. If the settings are correct, the individual points are ticked in blue. You don't need a big expertise to start a building job, which is really convenient to use. On the AM100, you can also do some maintenance on your own. An excellent help is provided by step-by-step instruction in the user interface. Just for example, the change of a coda lip. Later we will see more details about the user interface in a video. Besides of AM100 and AMpure and software, we are offering accessories which you need to have a complete system. These are suction unit, chamber oven, annealing furnace, gas generator, and metal bandsaw. As I told you in the beginning of the presentation, part of this webinar are some videos which are showing the different steps of the complete digital hybrid workflow. Let us start with the first video, how to work with the CAM software and prepare the dental restoration in the CAM software for the printer.
For metal printing and remilling of objects with CORiTEC machines, we need the CAM applications ICAM V5 Smart and ICAM AM. After selecting ICAM V5 Smart, we use the New Job button to select the milling machine with which the remilling work will be carried out later. We select the material, cobalt chromium, and the machine holder on which the 3D job will be built and reworked afterwards. After confirmation, a window opens to select a suitable construction type for the remilling, for example, bridge. At the same time, we load our two project files in STL format from the browser into the holder. After confirmation, the two objects appear on the holder. They show up in red because there are some overlappings. Click on an object to highlight it and use the positioning arrows to move each one until both appear collision-free on the base plate in gray. You can lift them up or lower them, tilt them, just bring each of them in any suitable position. The button at the top left allows us to inspect the objects step by step from standard perspectives without having to rotate or tilt them with the mouse. Next, we want to create the supports, which is handled in the software ICAM AM, so we must export the STL file there. Create the supports generated by the ICAM AM software, also named the slicer software. Click the button to get there. This is where the job from the ICAM V5 Smart software with all the orientation geometries is transferred. Now we need to create the supports. Click the icon and after a short while you will have them constructed. Hundreds of tiny props are built as supports that will carry the objects in space upon the building plate. They can be viewed from different perspectives, for example from the bottom, where they appear as small dots. These supports can now be edited. Each one can be moved or deleted if superfluous. If supports appear inside cavities or at inappropriate place, delete them. Different perspectives help to get a good image about the whole construction. If the supports are all okay, we create the print file by slicing. This is the principle how the laser at the end will act to build it slice after slice, layer by layer. Click on the pyramid button and add, for example, the descriptive name demo plate to the end of the print file to distinguish it. In a simulation, we can now have a preview to examine the printing process layer by layer and inspect it moving forward and back. If the structure meets our requirements, we close the simulation and switch over to the print button. This will now open the AMconnect remote software to transfer the print job we have just created directly to the job queue of the AM100 machine. Everything now has been done and we are ready for 3D printing. But we already have the remilling in mind and switch back to the ICAM V5 Smart software to generate the milling file. The purple colored areas are those that need to be remilled with the aim to reach a perfect engineering fit for the cavities. The details of a milling strategy is displayed, showing the individual steps of the milling process. A milling cutter list provides an overview of the required tools. The milling job now is generated. Now the work of building the job with the CORiTEC AM100 machine begins.
Okay, the second video describes how to prepare the building platform in the AM100 printer and how we start the restoration in the software.
In this step, we will learn how to prepare the AM100 3D printer and start the job in 6 simple steps. The machine already is switched on, the operator is logged in, and we see the screen of the machine's monitor. You see a general overview and, on the left, the menu with the 6 options mentioned before. In the Job Manager, we select the construction job that we had previously nested. In the area on the right, there is additional information about the job, such as the number of layers, the powder required, and the printing time, a total of 7 hours and 22 minutes. We switch to the menu item Build Module. The Build Module is shown here. It is inserted and electrically connected. So far, everything is fine. We see the dark blue tick behind the menu item. In the powder supply menu item, we can check the powder supply. A carousel with 5 cartridges is shown. 3 of them contain powder and are colored blue. We have enough powder in stock, represented by the blue bar above. The powder requirement is indicated by a small black line inside the bar, so there is enough powder. We also see a blue tick next to the menu item. The menu item Overflow shows the overflow container and the overflow cartridge. Both are highlighted in gray and are therefore empty. This means that the elements are ready for the next job, which is indicated by the blue tick. In the maintenance menu item, we see the display for the gas filter and the oxygen sensor. The gas filter has been replaced lately and the oxygen sensor calibration is still valid, so both are okay. In the last item, First Layer, we prepare the first layer of cobalt chromium powder. To do this, we select Supply a lot of powder and Coat. The wiper immediately starts to lay out the powder. In the first passes, a lot of powder is laid out so that the spaces between substrate plate and adapter plate are filled as best as possible, and then an even first layer can be laid out over the round building plate. You can now see that the round building plate is shimmering evenly and that a wafer-thin layer of powder has been applied to the entire building plate. We finish the process of laying out the first layer and the menu jumps back to the build job, which we check again and confirm accordingly. In the menu on the left, you can see the file name of the print job, the number of layers, the start time, the end time, and the amount of powder required for the job. Now the inertization process begins. The building chamber is flooded with nitrogen to repress the oxygen. The blue bar shows the progress. You can switch the display back to the inerting process. You can see the default settings for residual oxygen and the nitrogen flow rate. The target value for residual oxygen is only 1.5%. Above, see the flow rate of the inert gas. The set value here is 1.2 meters per second. The value of the residual oxygen indicates how long the inertization process will take. If the residual oxygen goes down to 1.50%, the building chamber is sufficiently flooded with nitrogen gas and the laser will start automatically. At the beginning, you can brightly see the 3 orientation geometries that are lasered on the outer edge. Then the sintering of the metal powder by the laser begins inside the plate. We switch to the progress view in the info menu, where we can track the current status. Currently, layer 3 is in progress. Layer 4 is produced immediately, followed by layer 5 and so on. In order to track the print job on a mobile device, use the AMconnect app. You select the machine and immediately see the current status of the machine's print job. The file name, the current layer and its total number, the remaining printing time, the powder supply and the status of the overflow container. A static image of the building chamber is generated and displayed every 3 seconds. Further down, the job queue is displayed so that you can track the status of your machine at any time.
Okay, this was our second video, which showed us the preparation of the building platform in the printer. Now, in this third video, we show you how to unpack the printing job in the AMpure and reuse the powder. Enjoy!
In this video, we see how to remove the print job from the AM100 3D printer, insert it to the AMpure sieving station, and how to remove surplus powder for reusing it. You will need a brush, a vacuum cleaner, and isopropanol wipes. When opening the building chamber, it is the only phase in which we have powder contact. This is why the operator wears a lab coat and an FFP3 mask and rubber gloves. First, all front elements are freed from powder. The baffle pipe is removed, shaken off, and vacuumed at the critical points. The remaining powder on the base surface is carefully swept into the build module and into the overflow container using a brush. In this way, as much material as possible is collected for reuse. All elements are carefully cleaned with the brush. The material that cannot be collected with the brush is vacuumed off the construction panel with the vacuum cleaner. The build module is electrically disconnected and the socket is covered with a cap. The build module now gets mechanically separated from the construction table, moving it manually by a lever. The build module is lowered and can now be taken off and transported as a whole into the AMpure sieving station using a lifter trolley. There is a cover lid for the build module that can be placed on top to prevent powder material from escaping from the inside due to air turbulence or to prevent other particles from entering. We can do without this additional handling here in this situation because this step-by-step action doesn't require it. Docking the build module to the AMpure is carried out using the same lever mechanism. There is an insertion cone on the underside of each blue handle of the build module. Both fit into the respective groove to the right and left, so that the right positioning is predefined. We check whether the build module correctly has snapped in and fix it mechanically by lifting it up with the levers. Now, to connect it electrically, the protective cap is released and the plug is inserted and locked in place with a rotary knob. The doors of the AMpure sieving station are closed and from now on we no longer have any contact with the powder. Before we start unpacking, we want to clean the building chamber of the AM100 with isopropanol wipes to prepare it for the next job. Excess powder is fed into the overflow container during the construction process and is collected there. For later recycling, the powder is transported from the overflow container into the overflow cartridge, which is located in the lower section of the machine. So let's move to the AMpure sieving station. There are two buttons inside the sieving station to move the build module. One for the upward movement, the other for the downward movement. The powder material slowly comes to the surface and you can start to wipe the excess powder with a brush into the overflow container of the AMpure. All excess material is wiped into the overflow container step by step. The construction plate can be released with a twisting motion. The bayonet catch is released and any further excess powder between the supports on the build plate is shaken off and swept into the overflow container. After all is clean, we can open the door and take off the base plate with our metal printed project. And it looks fantastic.
Okay, now in our last video, we show you how to prepare the printing job for the remilling in a 350i Pro Plus. machine, and you can see how the remilling process in the machine is working. Enjoy and have fun for the next video.
Here we see the annealed and cooled work of which the cavities are to be remilled in the next step. For this, we have a modified holder, the hybrid holder for the 350 Pro series. There are 3 hemispherical asymmetrically arranged orientation geometries on the build plate, which fit into the grooves in the holder. This ensures precise orientation of the build plate in the holder. The orientation is correct so that the clamping ring can be screwed on. A suitable torque screwdriver is supplied with the hybrid holder. It is essential that the screws are tightened to the appropriate torque, which is exactly 1 Newton meter. The build plate is now firmly seated in the holder and can be clamped to the machine. The 0-point clamping system is activated and the holder is firmly seated. The corresponding milling program had already been loaded so that the milling process can begin immediately. Now the milling process starts. The tool is measured and the cavities defined in the file which we initially had prepared are now milled. This ensures a perfect fit. First, the cavities are machined with the 2 mm milling tool. Then the tool is changed to a 1.5 mm tool, and finally the cavities are finished with a 1 mm milling cutter. The work has now been milled, and you can clearly see how the cavities differ in their material surface from the other parts of the work. We can release the holder and unscrew the build plate from the holder just as we had previously screwed it on. Now we can inspect the result, and the next step is to detach the work from the metal plate. This happens by the use of a metal bandsaw.
Okay, so as you saw in the video, a 3D touch probe is not necessary. The blank holder should be only calibrated one at a time, and then you can use the remill function in combination with the AM100 printer. Yeah, and then we have the result. I will show you the result in the camera. So as you can see, we have the results here, which were milled. I will show you another plate. This is a 4x plate. We milled there, we printed 3 from 12 removable partial dentures, 4x. And here we have an example, on titanium with different indications for restorations. Okay, let's take a look on the battle card. In this overview, we've chosen 5 other printers to compare with our printer. What we can see is that the AM100 has the biggest printing plate compared to the other printers. None of the printers has a substrate plate for hybrid processing. For a safe and healthy work with handling with the powder, we have the AMpure Unpack station. Additionally, The sieve station can be used for recycling of the powder. A validated workflow is given and secured by imes-icore. For the slicing software, ICAM AM, CAM software V5 hybrid, machine series 350i and 650i, cobalt chrome and titanium powder. The ideal size of a room is between 15 to 20 square meters. There you can place the printer, the AM100 Pure, and the accessories you need. Also, there's enough space to place milling machines for the hybrid milling. It means in one room you can set up the complete processing chain. So let us summarize all important points which we have learned today. First, adjustable focus diameter for fast and mass production. Second, 25 kilogram powder magazine for a 24/7 production. Third, a big building plate with 150, 150 and 150 millimeters. With this, up to 250 units can print it out. But fourth point, imes-icore is the one and only manufacturer who is providing a hybrid solution with own products. For this solution, we are using a substrate plate with a diameter of 150 millimeter, which fits automatically to imes-icore machines. The next important point is that with the unpacking and sieve station called AMpure, the customer has the big advantage that he not get in touch with the powder and save up to 90% powder because of the recycling method in the AMpure. The complete workflow is validated by imes-icore. All the components like software ICAM AM, ICAM V5 hybrid, the hardware like the printer AM100, the cobalt chrome and titanium powder, and imes-icore machines are all together aligned in one digital process. Okay, so
now we will answer some received questions. So the first question is it possible to add custom supports to the software?
Yes, you can create your own supports for different types of restorations.
The second one, do you need to calibrate the scan field of the laser in order to make sure the laser position on the build plate is correct?
Yes, of course, we perform the calibration of the laser during the first installation or during the annual maintenance.
Can I use argon in the printer?
Yes, it's also possible to use argon as a protective gas.
How often maintenance must be carried out?
For single shift use, only once a year. And if the machine is operated in more than one shift, we recommend half-yearly maintenance intervals.
Are there different annealing oven programs for the different applications?
Yes, we supply two pre-configured programs with our furnaces, one for standard annealing process, another for restorations with the residual elasticity, such as removable partial dentures.
Which slicing software you need for the hybrid process?
ICAM V5 Smart or Expert with the hybrid add-on. Okay, so that's all. Thank you very much, Alex. Thank you. If you receive more questions, I'm not sure, then we will answer them later, not later, the next days through email. Yeah. Okay, ladies and gentlemen, the distributors and customers, thank you very much for your kind attention today. We also offering workshops in our headquarters. Invite you to show the system and complete workflow in detail. Feel free to contact us if you have further questions or if you need more detailed information. So have a nice day, evening, and see you soon, hopefully. Bye.
Thank you. Bye.